The CLO for this lesson is that students will be able to analyze, in writing, data using scatter plots and association, as well as the following language: if-then statements, scatter plots, data, and association. So what do you think you're going to learn how to do in this lesson? Okay, so we'll start with the vocabulary. So when you're making a scatter plot, what a scatter plot is a bunch of points on a graph. So let's say I got this graph here, and there's a point there, and it's all scattered around. So scattered just means all over the place, and plot just means on a graph. So there's all these points on a graph, and it's called a scatter plot. So scatter plots are usually about data. And so data, each point is a data point. And data usually comes from a study. So it's information from a study. Scatter plots are used in real life a lot because they represent things that we're studying in real life. So for example, X might represent what time it is, for example. Like maybe this is data from a single day, and they recorded what time it was. So this might be 1 in the afternoon. Let's say they're doing afternoon only. And then we could have 2 in the afternoon, and 3 in the afternoon, and 4 in the afternoon, and so on and so forth. And then Y might be representing how many cars pass by your house that you see. So if this is our situation where X is what time it is and Y is how many cars there are, and let's say this is 1 p.m. and this is 1 car, this is a data point saying at 1 o'clock you saw 1 car pass. But then let's say this point up here is saying on a different day at 1 o'clock you saw 3 cars pass. And then this point up here is saying maybe on a different day you saw 5 cars pass at 1 o'clock. So you're collecting all your data throughout multiple days. And so this is a scatter plot. And we're going to learn a lot about scatter plots because this lesson and the next lesson deals with scatter plots. For this lesson, we're going to focus on something called association. The word association by itself just means how they are related. So when you look at these points, how are they related to each other? And that's what we're going to talk about for different scatter plots. What are the different types of associations they can have? So there are many, many types of associations with scatter plots. And we're going to talk about different types. So one thing they always want to know is it a linear association or not a linear? Well, the word linear just means straight line. So a linear association is when their data points seem to be following a straight line. So what I mean by that is it's not going to just go in a straight line all the way up. But if it sort of looks like it's going up in this way that I could draw a straight line through it, or if I zoomed out, if it would sort of ish look like a straight line, then it's a linear association, like this. However, nonlinear associations is when the data points follow any other pattern. So other patterns they could follow. They could have no pattern. It could look like this, where there's no pattern whatsoever. Another nonlinear pattern might be a curvy one. So it kind of starts slow, but then goes up real fast and like curves up like that. So this is not linear, because if I drew a line following what the data did, it would kind of curve up towards the end like that. It's not just curving up that's nonlinear, it could also curve down. So it's starting to ish follow a straight pattern, but then it'll like curve up. So that if I were to try to draw a line through it, it would curve at the bottom. Another nonlinear one is if it kind of makes a U. So it starts to go down like this, but then it comes back up, all the points. So this one's not linear, because it's only linear if the data seems to be going in a straight line direction. So they're always going to want to know if it's linear or not. They're also going to want to know if it's a positive or negative association. So you always read a graph from left to right. And as you start on the left side and move to the right, it's positive if it's going up over time. So for example, it's a positive association if we start and then start going up. It could go up in a straight line like this, or it can even start curving up, but it's still positive because it's going up over time. For a negative association, you're still going to read the graph from left to right. However, it's when it's going down. So if it starts and then from there starts to kind of move in the down direction, it's negative. And right now, this would be negative and linear because it's kind of going straight. But then once I start to curve it, it would be negative and not linear anymore. So far you have two ways to describe them, either linear or not, and whether or not it's positive or negative. The last type of association they care about you knowing is how strong or weak it is. So you can have some associations that are almost perfect, and almost perfect associations follow the pattern so closely that it almost makes a perfect line. So what that means is, like, let's say this is my first point, and this is my next one, and my next one, and my next one, my next one. It almost looks like I could draw a perfect line through these data points. And it almost looks like it's a part of a line, even though it's not, because it's just random data points. This association's almost perfect. It could look like almost a straight line and be almost perfect. It could also look like an almost perfect curve. And also be an almost perfect association. Versus if I drop to the other end of it, no association seems to follow no pattern at all. Like there's no equation that it looks like. It doesn't look linear. It doesn't look curvy. It doesn't look like a U. It just kind of looks all over the place. This one has no association. I couldn't tell you if it's positive or negative because I don't know if it's going up or down over time. I know it's definitely not linear because it's not following a straight line. But also, it has no strength. It has no pattern at all. However, a weak association sort of follows a pattern. So for example, a weak association might look something like this. The points are kind of far apart, but overall, it's still going up with time. It's very weak, but it's still happening. So this would be considered a weak association. What makes it stronger is if the points are closer together and it's following the pattern more. Follows a pattern, but not perfectly. So an example of this is if I take the scatter plot and then add more points that clearly show that it's kind of going up and they're kind of like they're close together. You can see the pattern a lot more clear. This would be considered a strong association. It would be even stronger if I got rid of some of these outside points if those points didn't exist. Now this is a really strong association. But if all those points were even closer together, and it almost makes a straight line like this, then it would be called an almost perfect association. So the strength of it, whether it's weak or strong or almost perfect, is kind of based off of, are the points really close together? Do they seem to be, if I drew a line, would it hit most of them? Because if it would, then it's really almost perfect. However, the more further apart they are and the more spread out, the weaker it gets until it's completely spread apart, and that's where it has no association. So let's say you're going to do a study that's going to chart how many cups of soda that somebody drinks in a given day, and that's going to be X, and then you're going to also ask them how much they weigh, and that's going to be Y. And you did it on 4 different groups of people. Let's say group 1 was like freshmen, sophomores, juniors, and seniors, or something, 4 different groups. And so you graph their data on 4 different graphs. And then so you end up with 4 very different looking scatter plots. So every single study gave you different results. But let's talk about what each set of results is saying. So first of all, is this one linear or nonlinear for group 1? Group 1 is linear. Is group 1's data positive or negative? It's going up from left to right, so it's positive. Finally, is group 1, does it have a no correlation, weak, strong, or almost perfect? I personally would say this is almost perfect. However, if you had told me that you thought it was just strong, that would be acceptable too. Let's do the same thing for all the groups. Let's first list their associations. For group 2, is this linear or not? It's definitely linear because you can draw a straight line through it, and that's kind of what the data is doing. Is it positive or negative? It's still going up over time because the data is kind of starting down here and then going up. And how strong is it? I would say this is pretty strong. For group 3, is it linear or nonlinear? It is not linear because if you try to draw a straight line, if you see at the end, the data kind of curves up, like right at the end. So it's not linear. Is it positive or negative? It's negative because over time it's going down. And then it kind of curves up a little at the end, but mostly it's negative. And how strong is it? This one's pretty weak. I wouldn't say it has no correlation because it definitely seems to be going down and then kind of curves. But it's close to having no correlation. It's very weak. Finally, for group 4, is it linear or nonlinear? This one's also not linear because it's definitely curving the data. Is it a positive or negative correlation? It's definitely positive because over time it's going up. Note that I just used the word correlation instead of association. They mean the same thing. And finally, how strong do you think this association is? It's really strong. It's not, it might even be almost perfect. There's a lot kind of clustered down here that makes it not almost perfect. Again, if you put strong or almost perfect, I would give you credit for it. So now that we've identified them, let's talk about what it's saying about the data, about how many cups of soda you're drinking and how much you weigh. In group 1, as X is going up, meaning more soda, because X is about the soda, note that X is the soda part. So as X gets bigger, the dots are going up. So the weight's going up as well. So this one, because it's a positive correlation, it's saying that the more soda you drink, the more you weigh. And graph 1 makes sense, right? The more soda you drink, the more weight you have because you're drinking more sugar. The fact that it's linear would probably tell me that the data is changing in a consistent way. So the word consistent means it's doing the same thing. Like it seems to be going up the same amount each time. When things are linear, they're pretty consistent. Or another way to say it is changing. Instead of saying changing in a consistent way, you can say at a steady pace. So what I know about the linear is the fact that the data is changing in a consistent way or at a steady pace, whatever you want to call it. And then it's saying that. So this is what it's saying, that the more soda you drink, the more you weigh. So that's the positive piece. The fact that more soda equals more weight. It's going up and up. And the last thing to talk about is the fact that it's almost a perfect correlation. Because it's so strong, what it's basically trying to say is this is very, very, very true. Because so much of the data is following that pattern. So because it's almost perfect, you would say it's a very true fact. So graph 1 is suggesting that this data is changing in a consistent way at a steady pace, claiming that the more soda you drink, the more you're going to weigh. And they're saying that's a very, very true fact based on this set of data right here from group 1. Group 2's data looks very different, and so it's suggesting something else. So if I do this for group 2, this one, the data is changing. Also in a linear way. And linear means that it's consistent or at a steady pace. So far, these are both the same because they're both linear. They're also both positive, so they're both also saying that the more soda you drink, the more you're going to weigh. So far, 1 and 2 are suggesting the same thing. The difference is that this is almost perfect. You can almost take it like it's a very true fact. This one, it's a bit weaker. It's still a strong correlation, but it's not an almost perfect one. So if you're only looking at this data, you would have to say that it's not suggesting that it's a true fact. But it's more likely saying that this is most likely true. We're not sure of that, but it's most likely true based on the data. Group 3 super changes things up. So, because it's curvy, because it's not linear, the data is changing. And it's kind of going down like really fast and kind of curvy. So that's what people say, in a fast and curvy way. The fact that it's negative is suggesting something different than this. It's not saying that the more you drink, the more you weigh. Actually, it's claiming the more you drink, the numbers are kind of going down since this graph tends to be starting up here and moving down, and then it spikes back up. So, really, the data is saying that the more soda you drink, the less you'll weigh because the fact that the correlation is more negative. It's saying more soda, the weight's going down for a lot of these points. However, we noted that this is a very weak association. And because it's a weak association, it's maybe true, maybe, but we're not so sure because the association's not very strong. But maybe it's not true. I mean, maybe it's not true here. All of these could maybe not be true. However, this one is more likely to not be true because of how weak the association is between them. And finally, for the last one, again, if it's not linear, it's changing in this way that's pretty fast, like it's shooting up really fast. And it's curving. So the data is changing in a fast and curvy way. So that's what the nonlinear is saying. The fact that it's positive is again saying more soda, more weight. Over time, with more soda you're drinking, the weight's going up with this set of data. The more you'll weigh. Because this one's going up over time, so with more soda, you'll have more weight. And that's the positive part. And the fact that this correlation is strong or almost perfect, you can say this data is suggesting that you should take this as a fact, or you're pretty sure it's true, right? It's most likely true, or it's very true. And depending on what you said, you can choose. You can say this is, since I said it was only a strong correlation, I would say this is most likely true. And I don't have to use the words most likely. I could also say probably or is. And that's it. So, our goal was to be able to analyze data using scatter plots and their associations. So, go ahead and explain to me what exactly you learned in this lesson.